like any of the three meals. And the answer we got was 11. Okay? Can I have your attention? The answer was 11 because out of the 80 people, 69, okay, like to eat at least one of the three meals. Okay, so if you find the difference between 69 and 80, get 11. Now those 11, they didn't like any of the three meals. Okay, then B, we drew the Venn diagram. Okay, the one which I did in the other class is this one here. Okay, but it's the same thing. Okay, the same as the one that we did yesterday. Then C says determine the value of X. Well, before I start talking about this question here, it's very important for you to know that for your probability, which will be the last question of your paper one, right? There are probably, I would say, three scenarios. You can get, okay, it's obvious that you get a grade 12 question. That's obvious. You can also get a grade 11 question. Now, the grade 11 question, it has got three types of questions. There is a Venn diagram, which we are going over now. Then there is also a tree diagram. Then there is what's called a contingency table. So you can get any one of those three. Normally, they don't test two of them at the same time or three of them at the same time. They bring one. So for your trials, you don't know whether they will put a Venn diagram, they're going to put a question on a tree diagram, or they'll put a question on a contingency table. So you have to come prepared to answer any question on any of those three. Then there is also another case where they bring a question from grade 10 based on the concepts that I introduced on Tuesday, that is mutually exclusive events, complementary events, and the addition rule of probabilities. Okay, so you have to be ready for any of, and it's only 15 marks. Probability is not a major topic, but it can boost you if you want to get a very, very high mark. But it's not a major topic. It's not a topic that I would encourage someone to spend too much time on. Okay, I'm not saying you neglect it, you should neglect it, but it's not a major topic. Okay, you can write your maths paper one and get a distinction without answering any one question on probability. It's very much possible. All right, so here, if you want to find the value of X, okay, this is how you find it. To go to your Venn diagram, okay, which I hope you got in front of you, okay, remember the total in the sample space, NS, is equal to 80, okay, 80 people. That 80 includes this level. Okay, so there are two ways of calculating X, two ways. I'll start with the first case where you are working with the total in the sample space. If you want to calculate X, okay, all you have to do is we add these values that are in green. So we add that 6, we add this 14, plus that 10, plus the 9, plus this X, plus that 14 minus X, plus the 21X, plus this 11. We add all of them. Their total will be 80. Okay? But for you to get the correct answer, you must have done the Venn diagram correctly. Okay? Being aware that in probability, we don't get negative answers. So X can never be negative. X has to be a positive answer. So if your Venn diagram is not correct or there's a mistake, if you come up with your algebraic expression and you get a value of X which is negative, it's a sign that you did something wrong. Okay, so you add all those values in green, including the ones that have got X plus this 11. That is if we use our NS, which is 8. Now if we do that, you come up with this equation. So it will be 80 plus 11 plus 21 minus X plus X plus 14 minus X plus 9 plus 14 plus 10 plus 6. These values, I'm getting them from the Venn diagram. Okay? Now, that is for your grade 89 algebra. Right? This minus X and that plus X, they cancel out. So you're left with this minus X. Then you add the integers on the right hand side. You will get 85. Now once you get here, you should start smiling. Because the moment you take this minus x to the right, you end up getting 85 minus 80 gives you a positive 5. So x is equal to positive 5. Okay? But to get x, you must get the Venn diagram right. If the Venn diagram is not right, then you won't be able to get the correct value for x. Yes? Sorry? Well, generally, 3 marks of 4. 3 marks of 4. But it's very important because, like in this question here, the Venn diagram is the key to getting all the questions that are underneath correct. It's not right, we have a problem. Okay? Alright? Well, it will depend now. If the examiner is very strict, you don't get a CA mark, then you get 0 for everything. Okay? But if they are, you see, with probability now, you can't get a CA for a negative answer. It doesn't make sense. You see now, and you can't get a probability which is more than 1. So even if we say we give you CA marks, but if you've got a probability which is more than 1, that does not make sense. So with probability, CA marks may not work. Right? So this is the solution to C. Once you get that x there, you go back to the Venn diagram. Right here, I indicated the correct values now of those elements that are in green. So where there is x here, I put 5 there in brackets. Then I subtracted the 5 from 14, I got the 9. Then I subtracted the 5 from 21, I got the 16. Okay, so I've shown you method 1. Method 2, okay, I'm not going to indicate it yet, but I'll just let you know. You can subtract these 11 from 80, you get what? 69. Those 69 will be equal to this 9, okay, so this 14 minus x, plus this x, plus that 9, the 10, the 6, the 14, and the 21 minus x. So you put the 69 to everything in green, excluding this 11. If you solve that equation, you also get a 5. Right? To the lesson. All right. Now, D1, it's very important for you to know that this topic has got its own language that you need to be aware of. Okay? Probability has got its own language that you need to be familiar with. And some of the language, it looks like it's everyday language, but the meaning in probability is different. So let's say D1 here, this is straightforward. Now it says, what is the probability written as a percentage? Okay? That one of these people chosen at random will like beggars. Okay? Now, here, it doesn't say beggars only. It says what? Beggars. Which means we need to take into account those who like beggars only, those who like pap and voice plus they also like a beggar, and also those who like all 3 meals. Okay? Because it doesn't say beggars only. Right? Why are you laughing? Okay. So if I go to the Venn diagram, okay, we have got these 9. Okay? They don't eat anything else. They only eat what? The beggar. Right? Then you have got this x here. Okay, remember this x here represents the 5. What x is 5. So we also include those 5. And then we also need to include this 9. Okay? Lastly, we need to include this 10 because they also eat a chicken. Okay? So if you add the 9 plus 10 plus 9 plus 5, you get 33. And that 33 is this one here. Okay? So the probability of eating a burger is going to be 33 over 80. Remember, the total in the sample space, NS, is equal to 80. That will always be our denominator when we are calculating the probabilities. Okay? So it will be 33 over 80 times 100, you get 41.25%. All right? Okay, sorry, boys. Then the next question was saying, likes fried chicken only. Okay? Well, there are some people who just like the chicken only. So these people, they like the fried chicken only. Right? For those who like fried chicken only, it's these 6 here. They don't eat anything else among those 3. They only eat fried chicken.
But you said you only eat burgers, huh?
Okay?
Yeah.
No. Are you talking about me or what?
Yeah, you said.
Yeah, in this case, I only eat the burger.
Why so?
Right? It's a choice.
So what's the
Okay. I'm a big fan of let's carry on. And also let's carry on. Okay. So let's come back to the lesson. Alright, so the probability, okay, of eating fried chicken only. Please, this is fried chicken only. So it's supposed to be F only. It's going to be about 6 over 80 times 100, which is 7.5%. Alright? Then, the next question, it says, likes burgers and fried chicken. Now, it's not strict here. It doesn't say burgers and fried chicken only. Therefore, if we want to determine those who like burgers and also like fried chicken, it means we have to add, okay, this is very important, stop laughing at this here, right? These 9, okay, plus these 5. Though they like half and boss, but they also like what? Burgers. Then these 9 plus, okay, plus these 14, these 10 here, and those 6. So we add all of them. Okay? Now if you do the math, you will find that we have got 16 here for pap only plus those 11. You add the 2, you get 27. Alright? Then you subtract from 80. So if you do that, you end up getting steak and fried chicken.
It's literally, it says on the video that company 50 and 90.
Okay.
There, sir, above the yellow.
About the yellow,
It
where?
says non-G non-burgers and fried chicken.
About this one here. These are fried chicken.
Yes, how many burgers and fried
Okay. Alright. Sorry. Is this intersection here? Okay, here we go. Alright. And can I have your attention? But I think I got carried away because of this laughing and talking. Can you just do me a favor? Just to help my brain to focus on this here. Let's just focus on it. Okay, no more laughing and so on. Let's get serious. Because I don't want to end up making unnecessary silly mistakes. Okay, so if it says burgers and fried chicken, the word "and" in probability, this word here, it means the intersection. That means what's common to both. Therefore, if you go on the Venn diagram, we have to add these 10. They like burgers and fried chicken only, but we also have these 9 here who eat all 3. So we have to include them. So we add the 2, we get what? 19. Okay, so that would be 19 over 80 times 100, then you get 23.75%. If the question was saying they like burgers and fried chicken only, then in that case we would only take this 10 here. If the question was saying burgers and fried chicken only, But in this case, it doesn't give a restriction now. So we have to include those 9. These 5 here, they don't eat fried chicken, so we can't include them. Are you following that? Yes. Right. Then the next question, which actually is the last one, it says they like half and or they like fried chicken. Now the word "or" in probability, it means "and." It's a union.
Yeah, union.
Okay? It's a union. So and so here, if it's a union of half and fried chicken, it means we add these 16, we add these 5, we add those 9, we exclude the 10, okay? We exclude the what? But we have to include that 10 as well because it includes people who eat fried chicken. So with 9 here plus these 10 plus that 61 and that 40. Okay, the only 2 values that we have to exclude here is this 9 here and that 11. Those are the only 2 that we have to exclude. Okay, because the word used here is the word "or." In probability, the word "or" means "and." The word "and" means intersection or what's common among those events. Alright? So, the total of those who eat half and also fried chicken is 60 people divided by 8 times 100, that's 75%. Alright? Okay, so we have got 3 sports here. We have got rugby, which is the one that I respect the most. Then we have got volleyball, and then we have got chess. Alright, okay. I tried to play it when I was in high school. Yeah. Okay. Alright, can you carry on this? Can you carry on this? Okay.
So what's
Oh, yeah.
Alright. Hey, can you stop that please? Let's carry on with the question. Alright. The first question says, draw a Venn diagram. Now I'm going to draw the Venn diagram, then to guide you to answer the question. Okay? Yes, because it's very important. So we have got 3 events. We have got rugby, and then we have got chess there, and then we have got volleyball. Right, can I have your attention? Okay, after the lesson you need to go together. Okay. Alright. A Venn diagram is very easy. Okay. As I told you yesterday, it's very easy to construct. Always look for what's common for all 3 events. So if you read this question here, we have got X learners who like what? All 3 sports. Okay. So we start with those X learners. We put those X there. Okay. Then you move on to combinations of 2 events. So we have got 14 learners who like rugby and volleyball, but no chess. So we just go to the intersection of rugby and volleyball. Right? So we have got rugby and volleyball. Now how many of them are there? There are 14. Now those 14, you put them there. They only like to play rugby and volleyball. They don't touch chess. Okay? Then we move on to another one. So we have got 12 learners who like rugby and chess but not volleyball. Okay? They don't touch volleyball, so over those 12. So it will be rugby and chess, that's 12. So the rugby and chess, that's 12. Right? Then we've got 15 learners who like volleyball and chess but not rugby. So it's volleyball and chess but not rugby, so we've got 15. Alright. Then The next part of the question, it says 3 learners did not like any sport. So those 3 we put them outside. Okay? Those 3 we put them outside. Now, we also need to determine how many of them like one sport. Okay. So, in total, we have got 52 learners who like rugby, right? So, you want to determine those who like rugby only, it will be 52. Let me use a different color. So, it will be 52 minus 12 plus x plus 14. So, that will give me 26 minus x. Then this will be 26 plus x. Are you following that?
Yes.
So this will be 26 plus x. Then those who like volleyball, in total there are 42. But we want those who like volleyball only, so it will be 42 minus 29 plus x. So that will give us 13 minus x. Okay? So we have 13 minus x. And then those who like chess, right? Listen. So, because you know what? I think because I was rushing. So this is supposed to be a class. Okay, thanks.